The most advanced space telescope ever built is the James Webb Space Telescope. In this video, we'll go over how this telescope works, how it was designed and built in different places around the world, and we'll explore the launch and journey into space. My name's Jared. I create 3D animations to show and explain how things work. If you'd like to support these videos and see behind the scenes on Patreon, then stick around until the end of the video. Looking up into the night sky, we can only see so much with the naked eye. When we get away from the city and other lights, we can see a little bit better. If we want to see even more, then we'll need to use a telescope. This allows us to see much farther and clearer into the night sky. There are several different types of telescopes, but in this video we'll look at a simple reflecting telescope. This uses mirrors to capture and direct the light. Light comes in and hits this large curved mirror, then bounces and focuses the light on a smaller secondary mirror until it comes into the eyepiece for us to view, or a camera to record the images. Think of it like collecting rain. The bigger your bucket, the more rain you're going to collect. The larger the mirror, the more light it collects, and the more distant objects you'll be able to see. A space telescope uses the same concept, but on a much larger scale. Looking into the vastness of space is a bit like looking back in time. Let me explain. Light travels fast, but it doesn't travel instantly. Light from the sun takes about 8 minutes to get to Earth, covering a distance of 149 million kilometers. If something were to suddenly happen to the sun, we wouldn't know it for 8 minutes. The closest star to us is just over 4 light-years away. That means we're seeing Proxima Centauri as it was 4 years ago. Think about looking at other stars that are thousands or even millions of light-years away. With a powerful enough telescope, we can see galaxies that are billions of light-years away. It's like a time machine. We're looking back into the universe as it once was. This helps scientists answer some very deep questions. It might also help us understand more about Earth and why it formed the way it did. Telescopes on the ground see light only after it passes through the atmosphere. The atmosphere contains shifting pockets of air that can distort images and actually can stop some forms of light from reaching the ground. You can solve some of these problems by putting telescopes high up in the mountains. We call this an observatory. But to see things really clearly, scientists have put telescopes high above our atmosphere. But getting anything into space is challenging and expensive. There's been quite a few space telescopes over the years, different sizes and launched for different reasons. Just note that this is not a complete list by any means. The most famous one you're probably familiar with is the Hubble Space Telescope. Hubble was launched in April of 1990 aboard the Space Shuttle Discovery. It was a 5-day mission in orbit around the Earth. The 5 NASA astronauts on board worked together to deploy the Hubble Space Telescope. Hubble is in low Earth orbit. It's about 540 kilometers above the surface of the Earth. When we look inside this telescope, we can see that light comes in and bounces off the primary mirror. The light goes to the secondary mirror and then gets redirected through the center to the scientific instruments in the back. These images are then captured and relayed back to Earth. Hubble was able to see much farther into the cosmos than ever before. In December of 1995, they did something that is now called the Hubble Deep Field. Scientists pointed Hubble at an area of the night sky that looked empty. As far as we knew, there was nothing there. They focused on the same spot for days at a time to reveal as much light as possible. What they found was incredible. It was completely filled with distant galaxies. Moments like this changed astronomy. Because the Hubble Space Telescope is in low Earth orbit, astronauts could return to Hubble to make repairs and maintain the telescope. There have been 5 servicing missions, with the last one being in 2009. It was well known that there were limits on what Hubble could see, no matter how long it stares at the same place. It turns out that light shines in different wavelengths. They call this the electromagnetic spectrum. You already know some of these: larger wavelengths for radio waves to listen to music, and smaller wavelengths to see if a bone is broken in your body. The human eye can only see a very small portion of this spectrum. A good example is thermal vision goggles. Watch what happens when we take a look through them. I can see there is a person inside of the house. The goggles allow me to see the infrared light. Essentially, it can see the heat of different objects. This is the James Webb Space Telescope, sometimes called JWST or just Webb. Launched in December of 2021, so it's still relatively new. It's an infrared telescope, which means it can see past the visible light spectrum, seeing things that even Hubble cannot see. Our understanding of the universe is that it's expanding. Galaxies are moving away from each other. When viewing galaxies that are far enough away, they're moving fast enough that their light waves are lengthened. This phenomenon is called the Doppler effect. This means that what was once visible light is now shifted into the infrared. This is known as redshift. It's no longer observable light, and a telescope like Hubble can't see it. Webb is not orbiting around the Earth. It's about 4 times as far as the Moon. That's about 1.5 million kilometers away in the cold darkness of space. Now, why would they put it all the way out here? Webb is positioned close to a Lagrange point. This is a place in space where gravity and other forces are balanced. When a spacecraft is placed here, it uses a lot less fuel to stay close to this point. When you consider the Earth and the Sun, there are 5 Lagrange points. L2 is an ideal place to put the telescope. It's still close to Earth but far enough away so the sun's light doesn't interfere. The telescope is detecting infrared light. That means that the instruments are very sensitive to heat, even their own heat. It needs to be cold and dark to be able to detect those distant stars and galaxies. Let's be honest, Webb doesn't really look like a telescope. If we look at Hubble, we can see the long tube-like shape, keeping out the ambient light to better focus on distant objects. James Webb Space Telescope is obviously different. It's placed far away from any light sources, and the sensitive parts will never see the sunlight. This diamond shape here is called the sunshield, and it's about the size of a tennis court. So how did Webb get here in space? Let's rewind the clock. Hubble was launched in 1990. Just before that, they held a meeting to plan for the next space telescope. It was a little slow getting things going, but construction finally started in 2004. Things were delayed quite a bit, and the project was almost canceled in 2011. It was a teamwork effort to get the different pieces of the telescope built and tested. This is an international project, so we have NASA in the United States, Canadian Space Agency from Canada, and the European Space Agency, which includes contributions for quite a few different countries. The hexagonal Mir segments were built in several places in the United States with final assembly in Boulder, Colorado, made of a chemical element called beryllium because it's lightweight, strong, and will hold its shape in the cold vacuum of space. There's an extremely thin layer of gold on top. Gold is used because it's a good reflector of infrared light. The Mir segments were shipped to Greenbelt, Maryland to integrate with the telescope. In Huntsville, Alabama, they started building the sunshield layers and it was then shipped to Redondo Beach, California. The very top parts of the telescope, the OTE and ISIM, these were both built in Greenbelt, Maryland at the NASA Goddard Space Flight Center. Here it is with just the structure. They used a giant robotic arm to do all of the heavy lifting. It would carefully lift up the mirror segments and delicately place them on the frame. This took about 3 months to install every single mirror. When it was time, Otis was packaged up into a special shipping container. This was called STARS. It was then placed inside of a C-5 airplane and flown all the way to Houston, Texas for additional testing. Inside this circular door is called Chamber A, the largest high vacuum chamber in the world. Otis spent about 100 days inside for cryogenic vacuum testing. This means taking all the air out and making it really, really cold. After this, Otis was packaged up again and flown to Redondo Beach, California, where they did the final assembly at Northrop Grumman. This happened in August of 2019. The telescope was launched all the way down here in French Guiana at the Guiana Space Center. It has to be all folded for the transportation. The next time it unfolds, it will be in space. First, it traveled by road pulled by a big truck, going very slowly, of course. There's some precious cargo on board. This time, instead of traveling in an airplane, it was loaded into a cargo ship to travel by water. It traveled from the coast of California, down through the Panama Canal, and over to French Guiana. It took 16 days to make the journey. This is the Ariane 5 rocket owned by the European Space Agency, 2 side boosters, main stage, upper stage, and the payload fairing. This is where the telescope was stowed. The finishing touches happened inside of the final assembly building. The telescope was lifted up, moved over, and carefully installed at the top of the rocket. Going into space is risky. We have extremely delicate cargo that will be violently shaken during the launch. After that, it will be exposed to the cold vacuum of space. This is a big part of why it took years to build and test. There's only one chance to get this right. The Ariane 5 rocket is a proven launch vehicle, the perfect choice for such a delicate mission. The launch took place Christmas Day 2021. At about 2 minutes and 21 seconds after liftoff, the solid rocket boosters are out of fuel. They both now detach from the spacecraft to fall back into the ocean. The main stage now carries the rocket upward. The payload fairing detaches at 3 minutes and 26 seconds. And there's Webb seeing space for the first time. At about 8 minutes and 48 seconds, main stage separation from the rocket. Now comes the upper stage ignition. The engine will burn for about 16 minutes, which puts us on a path away from the Earth. At 25 minutes, upper stage shutdown, and shortly after the telescope separates. It's finally on its own and on a path towards its final L2 destination. But of course, it will take about a month to get there. For 2 of those weeks, they will slowly unfold the telescope as it flies through space. All of this will be closely monitored by teams of scientists in Baltimore, Maryland at the Mission Operations Center. Let's go over the major milestones of the deployment. First, the solar array unfolds, very important to be able to power the telescope. Then the high-gain antenna to better communicate with Earth. It only took about a day and a half to travel out past the moon's orbit. Now we unfold the Unitized Pallet Structure, or UPS for short, the deployable tower assembly. Now we deploy the sunshield. It's an extremely delicate process that took a few days to fully complete. Now the secondary mirror is deployed. Now the primary mirror deploys, first the port side, then the starboard side. Before they can use the telescope, they do what's called mirror phasing. The 18 hexagon mirrors need to be adjusted. Tiny movements on each mirror until they are precisely aligned. This took many weeks to complete this process. The hexagons now act as one giant mirror. Remember how the Hubble Space Telescope could be serviced? They could send astronauts to fix things if it went wrong. With Webb, it's too far out there. It's similar to the Mars rover. It had to be designed so well because a repair mission is just not practical. James Webb is the same way. It has to work the first time. The first images from Webb were released on July 12, 2022. A major success and many new discoveries have been made. We're learning new things about the universe that no one expected. At the time of this video, December 2024, Webb has been operating successfully for almost 3 years now. $10 billion, 30 years in the making, and thousands of scientists and engineers to make Webb a reality. Now we stand on the edge of even more discoveries. What mysteries of the cosmos and our own origins will James Webb uncover next? Thanks for watching this video. For more space videos just like this one, make sure to check out the playlist down below. If you'd like a peek behind the curtain to learn more about how these videos are made, and even the chance to be involved in the creation process, then please head over to patreon.com/JaredOwenAnimations. Your support helps to grow my team and create these videos faster, but if Patreon isn't in the budget right now, you can always support by just watching another video. Here's the space playlist right here. Thanks again for watching, and I will see you next time.